In this screencast, I will demonstrate how to program custom checks associated to claims of the assurance cases. In FASTEN, we can model various aspects of the system, such as hazards, requirements, architecture, fault trees, or assurance arguments. Parts of assurance arguments are related to consistency or completeness criteria of different system or safety models. Let us take a closer look at the following assurance claim fragment found in the tutorial. The top goal claims that all hazards have been addressed, and this is supported by sub-goals, each related to a given hazard. Due to the fact that the hazards list is available as models in FASTEN, and that the hazards are linked to the assurance goals, this assurance fragment can be easily checked. We just need to check that for all hazards from the referenced list of hazards, we have a sub-goal addressing that hazard. Let us have a look on how the hazards list and the individual hazards are referenced from the goals. In the description of the goals, we use special words which reference the model elements related to hazards. Let us have a look at how the model is built behind the scene. For this, we firstly need to enable browsing models as they are built, not as they are displayed in the main editor. We enable the showing of members of root nodes in the logical view. After this, we can browse the children of the root nodes and their descendants. Let us look at our assurance argument. We can see the 3 goal elements and the 3 connections. Let us look at goal G01. It has a name property, G01. The description is composed of several words. Besides the plain text, a special word is used to reference the hazard list. The hazards list word references the list of hazards. By double-clicking on the reference in the logical view, the hazards list is opened in the main editor. In a similar fashion, when looking at goal G02, we remark that its description contains a set of words, and that there is a special word used to reference a hazard. By double-clicking on the reference in the logical view, the hazard is opened and selected in the main editor. In the same manner, the goal G03 has a description which references another hazard. Now, the checking rule can be formulated in English like this. Collect all hazards from the hazard list referenced in the top goal, and make sure that they are referenced from the children goals by using special words. For each hazard, from the list of hazards which is not referenced, we omit an error. This consistency check can be expressed with the help of custom assurance consistency checking rules. Such a checking rule can be created in the logical view on a model and is linked to a certain structured argument. And an assurance element from within. A checking rule has a natural language description, and the semantic is described with a closure, which takes as input the linked assurance element and should return a pair of objects. The first element is a boolean representing true if the check is success and false otherwise. If the check fails, the second element of the pair is a string with an error message. Let us look closer at the example custom check from the tutorial. It contains a small code fragment written in Java with helping constructs used to navigate through the model. At first, we start from the goal G01 and search inside for the hazards list ref word in order to obtain the referenced list of hazards. We collect all hazards from this list. Then, we collect all hazards which are addressed by subgoals of G01. Finally, if there are hazards in the list which are not addressed by any subgoal, then we omit an error with the error message listing the hazards which are not addressed. To run this checking rule, we first need to build the Java code by right-clicking on the model and triggering Rebuild Model. The check is now part of the model checking framework of FASTEN. Right-click on a model or solution and trigger the model checker. An error is presented that not all hazards are addressed. We can fix this error by simply adding a new sub-goal, which references the missing hazard. If we trigger the model checking again, the error disappears.